Hello guys, I am Munot and welcome to the School of Physics. So today we are going to start with the part 2 of our modern physics series. So the part 2 is the part 2 for modern physics. And what do you think it is? It is the photoelectric effect. Okay, it is the photoelectric effect. Now I'll teach you photoelectric effect in very simple lines. So I'll just draw a very rough apparatus of how photoelectric effect looks like. So here we have some sunlight. Here we have a current I flowing. This sunlight has some energy h mu, and h mu naught energy is absorbed, and then the electron when this light falls on this metal, the electron goes from here to here, and this is the photoelectric current. And then we have a voltmeter here, using which we regulate the voltage. Okay, so this is the photoelectric current. H mu electricity is there. So what happens is the H mu energy, the H mu energy of the photon, when it goes on the metal plate, it absorbs H mu naught energy, and then the rest energy, H mu naught energy, is absorbed to release the metal from the plate, and then the rest energy is the kinetic energy of the electron. Okay, the rest energy is the kinetic energy. So energy the radiation energy, we can write it as radiation energy is equal to absorbed energy to release the electron plus the kinetic energy. Now this thing is what we call as phi. This thing is what we call as phi, and it is also known as work function. It is also known as work function. Okay, and this energy, this kinetic energy, if we write it in terms of voltage, E into V naught, if this half mv max square is equal to E into V naught, then this V naught is called the stopping potential. This V naught is called the stopping potential. Okay, so I'll just draw a few graphs. And using those graphs you will be able to understand what happens when. So suppose we increase the intensity. Now we have learnt in our last lecture that intensity increases if the number of photons increases. So suppose we increase our intensity, number of photons falling on this metal plate, so the intensity is increasing. So when the intensity is increasing, what happens is the photoelectric current increases in proportionality. So when the intensity increases, the photoelectric current increases in proportionality. Okay, now the next thing that I am going to show you is what will happen if we increase the voltage. This voltage, if we increase, what will happen to the photoelectric current? So what happens is this photoelectric current increases to a point and then becomes constant, which is called the saturation current. So initially when we increase this thing, or let me draw it more properly. Okay, so when we increase the voltage, the photoelectric current definitely increases, but only to a point where this I becomes I max, and this I max is called saturation current. Okay, so with intensity we have seen, with voltage we have seen. Now what happens is, suppose after this I reaching the I max, if we reverse the potential to bring I to a zero, so what will happen is, suppose we reverse the potential, okay, and we try to bring it to 0, the potential to 0, and this is the current, okay. So I am reversing the potential. So this V naught is the potential at which this I, the photoelectric current, becomes 0. And you know what this V naught is? This V naught is the same V naught that we have used here, which is kinetic energy is V naught, like half mve square, the kinetic energy equals to, when we do it, EV naught. It is the same V naught equals to the potential when the current becomes 0, and that is called stopping potential. Now stopping potential also has some variations. So the stopping potential, it depends. So saturation current, it depends on intensity, like the higher the intensity, the higher the saturation current. So suppose this stopping potential, we have frequency, okay. So this stopping potential for different frequencies will be something like this, okay, right. So this is the voltage, this is the current. When current we bring it to down, so this is stopping potential 3, this is stopping potential 2, and this is stopping potential 1. So as you can see, the value of magnitude of stopping potential 3 is greater than magnitude of stopping potential 2 is greater than magnitude of stopping potential 1. So this stopping potential, it depends on the frequency of the sunlight that is falling on it. On the stopping value of stopping potential depends on the frequency of the sunlight falling on it, as in the more the frequency, the more will be the stopping potential. So for this, mu3 is greater than mu2 is greater than mu1, okay. Okay, now we talk about this frequency. This frequency mu naught, V naught or mu naught is also called the threshold frequency, and this threshold frequency, it doesn't depend on anything else but the nature of the metal. So this threshold frequency totally depends on what kind of metal are we using, okay. Now I'll draw a graph based on this thing, h mu is equal to h mu naught plus half mve square, okay, which is also E V naught, okay. So I'm rubbing this side. I hope these fundas are clear to you, okay. So suppose I draw this graph as, on the y-axis I am taking, on the y-axis, so rather than having this EV naught, I'll have rather than having this half mv square, I'll use EV naught, okay. Now suppose V naught is my y-axis, okay, V naught is my y-axis or x-axis, and mu is my y-axis. So this is voltage, and so if voltage is x, okay, and this is mu, so this is my x-axis, that is frequency, okay, this is my x-axis, okay. So EV naught will become equal to h mu minus h mu naught, okay. And so we can write V naught is equal to h mu by E minus h mu naught by E, okay. So since this is y and this is m, x, V is x plus c, this is the intercept, okay. So if we have to draw this graph, how will we draw it? Y is equal to V naught, okay, y is equal to V naught, or y is equal to the voltage, okay. Now this voltage, when x is equal to 0, this voltage becomes equals to 0, okay. So y is equal to mx plus c, So Y is equal to V naught. So this is the voltage. This is the voltage. This is the voltage, and this is the frequency. This is the frequency. This is the voltage, and this is the frequency. Okay. So this is the frequency, right? And this is the voltage. Voltage is the stopping potential. Okay, so we have to draw Y is equal to mx plus c. Okay, and this is x. Frequency is x, and here we have V here. Okay, V naught here. Okay, the stopping potential, and this slope is equals to h by, this slope is equals to h by e, and then this intercept, this value of this intercept will be equals to, this value of this intercept will be equals to h mu. Since this is a negative intercept, so we are taking it below the x-axis, so this will be equals to h mu naught by e. Okay, which is also equals to minus 5 by e. Okay, because since we know h mu naught is equal to the stopping potential, so this is stopping potential by e, this is the frequency, this is the slope h by e. Okay, slope is positive, and this is the voltage, or this voltage can also be called as, oh sorry, this is the work function. This is not the stopping potential, this is the work function, and this is the, on the y-axis we have the stopping potential. On the y-axis we have the stopping potential. So this is the variation of stopping potential with frequency, slope h by e, and this, suppose when mu is equal to 0, when this is equal to 0. So what is the value of x? This is the value of x, that is the threshold frequency. So this is the threshold frequency. How? I'll just show. When V naught equals to 0, h mu is equal to h mu naught. So mu is equal to mu naught. So this is the value of frequency when the stopping potential is 0, mu is equal to mu naught. This is an important curve. This comes directly in exams, in your board exams. This curve can come directly. You just need to know how to draw it, and even in your exams this might come. Also, the other common questions from and this is the most common equation from which the photoelectric effect will come, and then there will be some variation of photoelectric current with intensity or with voltage. So those are the common questions that come. Otherwise, photoelectric effect is a very simple topic to deal with, and I hope you really enjoyed this lecture. Very simple photoelectric effect. Just keep on memorizing the relations and the formulas, and I'm sure you'll be able to do all the questions in exam. Thank you for watching my video. Please subscribe.